Another method for allocating and representing an IP address is using the classless interdomain routing or CIDR notation. Prior to CIDR, IP networks were clumped into Class A, Class B, or Class C network ranges, and that allocated entire blocks and was very inflexible, and it could be wasteful. With CIDR, the most significant bits indicate the network prefix, and the least significant bits are the host identifier, very similar to the examples we've seen already. Looking at the right half of the screen, you can see that with 32 bits and IPv4, it's easy to work out how many bits are allocated for the hosts by subtracting the decimal number after the slash from 32. That gives you the number of bits remaining for the allocation of addresses. In this example of 192.168.1.14/24, we have 24 bits for the network prefix, that is the 3 octets of 192, 168, and 1, with 8 bits remaining for the host ID, which in this case is 14. Finally, 192.168.1.0/29 would mean that you're using 32 minus 29 bits for the network portion of the address, leaving only 3 bits for network IP addressing. That is only 8 available IPs for this range. There are also some special IP addresses that we should be aware of, and I'll highlight the most important ones here. 127.0.0.0/8 is the loopback IP range. And now that you know how CIDR notation works, the /8 means 127.anything is a local loopback. And a fun game to play is to actually set the loopback to anything besides the common 127.0.0.1 and just watch how many people it freaks out. Because a lot of people don't realize that loopback is much more than just 127.0.0.1. What is a loopback? Well, a loopback means anything you send out loops back inside the host. It never leaves the network interface, but is useful for testing or redirecting traffic back to the host. Much like a boomerang. If you get a range in the 169, that is a PIPA, an automatic private IP address. And that's what happens when you have a device looking for a DHCP assigned IP address, but not receiving one. It assigns itself an PIPA IP address. The final topic is the network sockets and ports. All network connections on a TCP/IP will use sockets. That is an IP address and a unique network port. An analogy to explain this arrangement is the use of a house share or a student digs or an apartment block. The main street address is the same for all the residents, much like an IP address of a computer. But you still need some way to target a specific apartment or person, and in networking terms, that's a socket. Each application will use its own port, and some of which are globally recognized, such as SSH using port 22, and a socket pair consists of the source and remote IP addresses, as well as the source and remote port numbers.